Good morning. Mathematics class of class 8. Today's date is 8 May. Or in Bengali, today's date is 25 Boishakh. All of you known to the importance of this date. Today is birthday of Vishwakobi Rabindranath Thakur. So we start today's class. Mathematics class, obviously. Today's class start with a Rabindra Sangeet. Okay. Then we go to our topic. First, we listen Rabindra Sangeet for 1 minute, 1 or 1.5 minutes with a video, obviously video of sunrise with this Rabindra Sangeet. Okay. Then we go to our topic today.
সীমার মাঝে অসীম তুমি বাজাও আপন সুর আমার মধ্যে তোমার প্রকাশ তাই এত মধুর সীমার মাঝে অসীম তুমি বাজাও আপন সুর কত বর্ণে কত গন্ধে কত গানে কত ছন্দে কত বর্ণে কত গন্ধে কত গানে কত ছন্দে অরূপ তোমার রূপের লীলায় জাগে হৃদয়ে ফুল আমার
Now we start our topic. I written here. Our topic is LCM and HCF of algebraic expression. So LCM and HCF are known to all of us in arithmetic. Not in algebraic expression, it's not known to us still now. But LCM, HCF or LCM GCD are known to all of us. First we find the LCM of 4 and 6 and HCF on 4 and 6. First we find the multiples of 4. Multiples of 4 are multiple of 4 are 4, 8, 12, 16, 20, 24 in this way. Multiple of 6 are 6, 12, 18, 24, 30. Up to. We listen the song. Which song we are already listening? Simar Maje Oshim Tumi. So obviously Oshim means infinite. So multiples are infinite. Clear? Multiples of 4 and multiples 6 are all infinite. And to find the HCF, we need factors. So the factors of 4 is 1, 2, 4. Factors of 6, 1, 2, 3, 4. These are finite or infinite? It is finite. That means Sima. That means Sima Maje Oshim Tumi. Oshim kongulo pai infinite numbers. Which are infinite? Multiples are infinite. And the factors are limited or finite. So we study with this song Simar Maje Oshim Tumi. Now how we find HCF and LCM, discuss this one. So just first write down the multiples of 4, 8, 12, 16, 20 and 24. Multiples of 6, 6, 12, 18, 24 and 30. First find the common multiple. Common multiples are 12, 24 and after that 36. These are common. The full form of LCM is least common multiple. Least common multiple. So least number of this is 12. So LCM is 12. That is LCM of, it is known to us, LCM of 4 and 6 is 12. Next, about HCF or GCD, greatest common divisor. So factors of 4 are 1, 2, 4. Factors of 6. 1, 2, 3, 4. So common factors 1 and 2. And highest of these two is 2. So highest common factor, that means HCF. The full form of HCF is nothing but highest common factor of 6 and 4 is 2. So LCM and HCF of in arithmetic is known to all of us. Today we discuss about the HCF and LCM of algebraic expression. After that, first LCM and HCF of numbers, that means in arithmetic, then we go to the algebraic expression. Okay. Next question, find the HCF or GCD of 5 p square q square, 10 p square q square and 25 p to the power 4 q to the power 3, that is q cube. Obviously these are in monomial form. Next we study about binomial, polynomials, etc. Obviously first monomial. First expression, here the first expression is 5 p square into q square. This can be put in the form 5 into p square means p into p, q into q. Second expression 10 p square q square, so 10 is equal to 5 into 2, p into p, q into q. 25 p to the power 4 q, sorry, this is q, not p to the power 4, it is q. So p to the power 4, q to the power 3. So it is then written as 25 means 5 into 5, p into p 4 times and q into q 3 times. Now we have to find out the HCF or GCD, that is greatest common divisor. So first we find the common divisor. These are 5, 5 and 5. These are common to all these three. So we write 5. And other than this, the arithmetic expression is not common here. Here is also 5 and 2, the separate things. Now common things is p in all the cases. So we write p here, another p here. So into p and no common p here, q. So into q, another q. So into q, that is 5 p square into q square. This is the HCF of the required HCF of 5 p square q to the q square, 10 p square q square, 25 p to the power 4 q. Is first find the in other way and not in this way also. First find the HCF of 5, 10 and 25. First find the HCF of 5, 10 and 25. So obviously by factorization method or division method we can find the HCF of these three, nothing but 5. Then the lowest term, lowest power of the variable. Here is p square, here is p square, here is p to the power 4. So common is, you can find this way also, p square. And lowest power of q, that is q square, q, which is the lowest power. Obviously q square is the lowest power. So you can write in this way also, 5 p square q square is the HCF. Now if the question is find the LCM, then with the same example, if the question is find the HCF and LCM, we have already find its HCF. Now how we find LCM of these three? Same, first write down the common terms. First we have to write down the common terms like that HCF. Obviously LCM is greater than HCF in general, not in all cases obviously. Okay, so first write down the LCM is, write down the common term. 5 is the common, and of course the other term also. Write down the other term also, and this is 2 into 5. The other terms 2 and 5 here. So right here. Next write the common term again. Common term is from this is p, another p, q, another q, and we have to write down the remaining term also. For LCM we have to write down the remaining term also. Here is the remaining term. Which are the remaining terms? Here already 2p, that means p into p are the remaining term, and 1q are also remaining. So write down here q. So first write down in the number common terms and the extra term, then write down the common term of the variable. P is common, so write phi. P another p is common, so write phi. Q is common, all the three, so write q. Another q is common, so write q. Then the extra term, there p into p, we write here, and another extra term is q, so we write here. So finally we get the LCM, and what is the value? 5 into 2, 10, 10 into 5, that is 50. How much? How many p's here? 1, 2, 3, 4, that means p to the power 4. How many q's are? 1, 2, 3, so q to the power 3. So LCM is 50, p to the power 4, q to the power 3. Or in other way, just find the LCM of p, q, etc. variable, and also find the LCM of 5, 10 and 25. LCM of 5, 10 and 25. Then we can also find this arithmetical number. Divided by 5, 2, 5, again divided by 5, 1, 2, 1. So 5, 5, 25 into 2, that is 50 again. So find the LCM of the number, that means numerical values. Find the LCM of the numerical values, and then find the algebraic portion. We find the LCM of any number, any 3 numbers, 2 numbers, 4 numbers, etc. Clear? This is the procedure, find LCM with the help of same example. Clear? Next we go to the next problem to find HCF and LCM. Next question, find HCF and LCM of 2 into x minus 4 and x square minus 3x plus 2. So first expression, here are 2 expressions only given, not 3 here. 2 into, and this is in binomial form obviously, and this is in polynomial form or trinomial 3. 2 into x minus 4, this remains same. These are in factorized form. 2 multiplied by x minus 4, so it is in multiplied form. So no problem at all. So we take the second expression. Second expression is equal to x square minus 3x plus 2. Oh, so first we convert in factor form, that means multiplication form. Then we find the HCF or LCM. So this is, we have already known middle term factor. So using this we find this x square minus 2x minus x plus 2, 3, that means 2 plus 1. From these two, x is common, we get x minus 2. Minus 1 is common, x minus 2. Finally, we get x minus 2 into x minus 1. Therefore, the common term between these two, first find HCF. So, excuse me, we have to find out the common term. First one, x minus 4, and this is x minus 2, x minus 1, and 2, and this is 1. So, there is no common term except 1. So, in this case, HCF must be 1. Therefore, required HCF, the common term is only 1. So, HCF is 1. Next, we find LCM. So, first we write the common term. There is no common term. So, all terms are present. From first 2 into this one, x minus 4, right here, x minus 4. Next, this is x minus 2, write down, and third term x minus 1. So, LCM is the product of these three. Product of these 4 with 2 included. So, LCM is 2 into x minus 4, x minus 2 into x minus 1. If there is no common term, if there exists no common term, 1 is common to all of these, so HCF must be 1. And for LCM, no problem at all. Product of all the factors, we get the LCM. And for HCF, just common term between these two. If there is no common term, then we write HCF is 1. Is it clear? It's okay, no problem. If there is no common term, then we write the HCF is 1. So we go to the next problem again. Next question, Find HCF and LCM of y cube minus 8, y cube minus 4y square plus 4y and y square plus y minus 6. So first expression, y cube minus 8. It can be written as y cube minus 2 cube. Now using the formula of a cube minus b cube, factorization formula, it will be y minus 2 and y square plus 2 into y plus 2 square, that means 4. Y square plus 2y plus 4. Next, second expression, take second expression, that is equals to y cube minus 4y square plus 4y. So first we see that y is common in all the three terms. Y is common. So first take y common. Then we get y square minus 4y plus 4. This is nothing but y minus 2 whole square. Y minus 2 whole square, that is y square, minus 2 into y, that is 4y, plus 2 square, that is 4. So if we write in this way, or you write in this way also, y minus 2 into y minus 2. The third expression, y square plus y minus 6, y square plus y minus 6, that is equals to, again use middle term factor, y square plus 3 minus 2, that is 1, and 3 into 2 is 6. 3 minus 2, that is 1, and 3 into 2 is 6. Sorry, into y minus 6. So it will be y square plus 3y minus 2y minus 6. Y is common, then you get y plus 3, minus 2 is common, then you get y plus 3. So final answer, y plus 3 is common, y minus 2. So factorization completed. Next we have to find out the HCF and LCM. Next we have to find out HCF and LCM. How we get HCF and LCM? Very easily. Required HCF. Required HCF. First find the common terms. We see that y minus 2 is common to all these three expressions. Y minus 2 here, y minus 2 in the second, and y minus 2 also here. So HCF is equal to how much? Y minus 2 first. Then there is any other common term? Most probably not. Most probably not. Okay, so HCF is y minus 2. And LCM. Required LCM. First write down the common term, y minus 2. Next write the other term. If common to the both 2, then we write again. Then the first one, y square plus 2y plus 4. No, only one, y square plus 2y plus 4. So it already done. Next, y minus 2, 1 y minus 2 taken. Another y into y minus 2 are left. So write down y into y minus 2. Y into y minus 2. And y plus 3 left. So write here y plus 3. Now write in arrangement form. First write y minus 2, y minus 2. This is nothing but y minus 2 whole square. And the remaining term, we already write these 2 and this one here. And the remaining term, one term is y plus 3, write down, and the last term y square plus 2y plus 4. Y square plus 2y plus 4. Therefore the LCM will be y into y minus 2 whole square into y plus 3 into y square plus 2y plus 4. And HCF is very simple. HCF is y minus 2. This is the HCF and this is the LCM of these three expressions. So how we find HCF and LCM? It is very easy. HCF means common to all the terms, and LCM common term also, and write down the remaining term also. Is clear too? Since it is clear now. Okay. Next, we start exercise 14. Sum number 1-4. Find the GCD of 3a square b square c, 12a square b to the power 4 c square, and 9a to the power 5 and b to the power 4. So first expression right here 3a square b square c. Second expression 12a square b to the power 4 and c square. And third expression 9a to the power 5 b to the power 4. So required GCD or HCF. So obviously first find the HCF of 3, 12 and 9. GCD of 3, 12 and 9. Here we find very easy. So GCD of numeric number is 3. And if it is not given the ABC, value of ABC, so we take the value of ABC all greater than 1. All greater than 1, that means it is not fraction. If it is fraction, then these are different. Say in the next class obviously what happened when these are fraction. So in this case let us assume if it is not given, so let us assume it is greater than 1. So we have to find out the HCF or GCD. So first find the common terms. So a square, and here is a to the power 5. That means a to the power 5. That means a square must present here. A square must present here. A to the power 5 means a square into a cube. By laws of indices, it is known to all of you. A square into a cube, that is a to the power 5. So it is known to you. So we take the common terms is a square first. Next, b square, b to the power 4 and b to the power 4. b to the power 4, b to the power 4 is common, but here only b square. So common to all these three. Which term is common? Not b to the power 4. In b to the power 4, b square is present. So we write b square. And c or c square are present. In the first expression c is present, in the second expression c square is present, but in third expression c square is not present. So GCD not in terms of c, so GCD must be 3a square b square, right? The common terms only. Or take in this case the lowest power of the variable which is common. Lowest power a square to the power 5. The lowest power of these three is a square, so we take a square. B square, b to the power 4, b to the power 4. Lowest power of b is b square, so we write b square. And c square, and c to the power 0 here. C is absent, so we can write c to the power 0. c to the power 0 is nothing but 1. So the lowest power is 0, so we write c to the power 0, or that is 1. Nothing to write here. So GCD is 3a square b square. If it is not given, the value of AB lies between 0 and 1 or etc., then we do it. Clear? If it is given, it discuss in the next class obviously. Okay. Next question of the same exercise 14, 2-4. Find the LCM of 11a square b into c square, 33a square b square c, and 55a square b c square. So here we write the first expression 11a square b into c square, second expression 33a square b square into c, and third expression 55a square b and c square. First we have to find out the LCM of 11, 33 and 55. What is the LCM of 11, 33 and 55? It's nothing but 55. It is known to all of you. Very simple question. Sir, it is very easy. So LCM of 11, 33 and 55 all are multiple of 11. So 55 is the LCM. So write down here 55 first. Next, just a square and a square is common. So write down a square. All are common. B square and b. For LCM, write down the highest power. For HCF, write down the lowest power. I repeat, for HCF, write down the lowest power. For HCF, write down the highest power. Again I repeat, I am telling you, if it is not given, the ABC lies between this and that. Assume that ABC are greater than 1. I repeat once again, like previous problem. So write down the highest power. That means a square is the highest power. In case of B, B square and B square and B. So which one is the highest? Obviously B square is the highest power. So write down B square. C square, C and C square. So highest power is C square. So this is the required LCM. 55 A square B square C square. 55 A square B square C square is the LCM of these three expression. Okay. Next question, question number 36. Find the HCF of x square plus 3x plus 2, x square plus 4x plus 3 and x square plus 5x plus 6. First expression, x square plus 3x plus 2. So this immediate term factor, x square plus 2 plus 1, that is 3, 2x plus x plus 2. If we take x common, x plus 2 and 1, x plus 2, and then we get the factors as x plus 2 and x plus 1. Second question, second expression, x square plus 4x plus 3. So same things, middle term again, x square plus 3x plus x plus 3. 3 plus 1 4, 3 into 1 3. So x is common, x plus 3 plus 1 is common, x plus 3, then we write x plus 3 into x plus 1, x plus 3 into x plus 1. Next, third expression, x square plus 5x plus 6. Write down x square plus 3x plus 2x plus 6. So it is x square, x is common, x plus 3 and 2 is common, this is x plus, sorry, this is x plus 3, 2 is common, then we get x plus 3 into x plus 2. Okay, now we have to find out the HCF. We have to find out the HCF. Clear? So HCF is nothing but the common. So required HCF. Find the common term. X plus 1, x plus 1, here is not x plus 1. So x plus 1 is not common. X plus 2 here, but here is not x plus 2. So there is no common term. No common term in all these three. X plus 1 here, x plus 1 here, but here is not x plus 1. X plus 2 here, x plus 2 here, but x plus 2 is not here. So HCF is 1. So HCF is 1. Question 37. Find the HCF of x square plus xy. Second expression is xz plus yz. And third expression is x square plus 2xy plus y square. Here the first expression is x square plus xy. The common term is x. So we take x common from these two, x into x plus y. In the second expression, this is also very easy. Z is common to the both the terms. So we take z common, then you get x plus y. This is nothing but x plus y. In the third expression, it is given that x square plus 2xy plus y square. Which is this? X square plus 2xy plus y square. Very simple. So write down how much? X plus y whole square. This is given the formula. So it can be written in this way. This is x plus y into x plus y. X plus y into x plus y. So we have to find out the HCF. That means write down the common terms, all these three. So required HCF is nothing but find the common. X is not present in the all, but x plus y, here is x plus y also, here is x plus y also. So the HCF is nothing but x plus y. This is the required HCF. Since x plus y is common to the all these three, x plus y, here is also x plus y, here is also x plus y. Therefore x plus y is the HCF of these three. Clear? It's okay.